In this exercise, we're going to be working on an application called Quiet Hacker News. And the main goal here is not to look at how to build the application, but we want to look at how to add things like concurrency and caching to an existing application. But in order for this to make sense, I need to sort of discuss what the application is, what it's doing, so that, as you start to add these features, you'll know what you're doing. So it's a really common tactic when you're learning a language to just go clone something that exists. This is why you'll see a lot of Twitter clones, a lot of Pinterest clones, things like that, because whenever you want to learn a language, rather than trying to figure out, all right, what features do I want, how will that feature work, if you just build a clone of something, you can generally skip a lot of that. You don't have to think about the UI or the user experience. You just, take an application you already know, you already use, and you build some simplified version of it. So if you're learning a language, I definitely recommend it as a great way to sort of solidify your knowledge of the language and to make sure you know what you're doing. So this application is a version of Hacker News, which I'm going to show you real quick. Let me zoom in. Hacker News is a news aggregation site. So, there'll be links like this. It's kind of like a specific subreddit is the best way to describe it. So if you've ever used Reddit, it's going to be like a specific subreddit, except it's its own website. And people submit stuff, they upvote them. You can see here there are comments. There's all sorts of different stuff you can do. Our simplified version of it is going to be much, much different. So let me go ahead and click on this. This is the version that this is based off of. So somebody who was learning Go and reached out to me at one point and showed me the project they were working on. I don't know if they have, there we go. So they made this version of Hacker News, which you can see here is really, really simple. It just has links. It skips any discussions, so it doesn't have comments. But also, if you post something on Hacker News that is just an Ask HN or something that's just discussion, it'll skip it from this list. So this list won't be exactly the same as Hacker News. And it's essentially just meant to be like a really simple version that doesn't allow distractions such as, getting sucked into the comments and the debates there and stuff like that. So I have all that working. A simplified version of it. I didn't take the exact code from this project that I linked. I took something very similar and I broke it apart so that it'd be easier for us to do this exercise. So my code is going to be in, let me go ahead and github.com/Gophercises/quiethn. It's all here. There's a main.go and you'll see here that this is, it's not too big. It's less than 100 lines of code, but this will actually start up a server. It'll return this handler that's used by the server, and this handler will, if you read through the code, it will start a timer, it'll get a client for the Hacker News, it will get the top items, and then it'll go through all the items in a for loop, and then it will get get each of these stories, and then as soon as it gets 30, I think 30 is the default. Yeah, as soon as it gets num stories, which is a flag you can set, and it defaults to 30, as soon as it gets 30 of those, it will break out of this for loop, and then it'll render the template with the top 30 stories. And if you look at like the isStoryLink function that I have here, it's really simple. It just says if the type is a story and the URL is not empty. So if the URL is set to something, that means that it won't be text, so it's not a discussion. And if the type is story, that means that, we're working on a story here, not a job posting or something like that. And that's all we want to show here, really. The only other thing that's really added here is this parse HN item, which basically just takes in a URL, tries to pull out the host name, so that if I go back, here's the example of it. When you're looking at a page like this, it'll show you the host over here on the right. It's, just a shortened version of the domain. And it's not perfect. Some of these will still have subdomains and everything, and that's fine. It's just meant to give you a rough idea of what site you're going to be linked to. So that's what's happening right now at the exercise, and I've got a screenshot of it here. What we're going to be doing for the actual exercise is the first thing is we want to add concurrency. So I think I have this. No, I don't have it running. So let me start it up real quick. If we load this page, you'll see that it's going to take a couple seconds to load. So I've got this timer here that shows you that it took 1.6 seconds, and that could vary depending on your internet, because when you load this page, right now our code will get all the top, get a list of all the top story IDs, and then it'll go through and manually get them one at a time. And what we're going to look at is a way to add concurrency, because obviously when we're waiting for this first story to load, well, we could really just start loading other stories at the same time. Our server doesn't have to sit there and wait for it. We could start loading 10, 20, maybe 30 stories all at the same time. When they come back, we can decide, all right, we've got all 30 stories, we can render the page now. And that'll allow us to speed things up because rather than, really sitting there and waiting for one at a time, we can have 10 coming in and, maybe they'll all load a little bit quicker. This is especially true whenever you have a ton of bandwidth. So, if you're running on like a DigitalOcean server or something like that, where realistically you could load all 30 stories concurrently and it's going to make your page load go from maybe 1 or 2 seconds to, something down as low as maybe 250 milliseconds or something like that. So it's definitely something you'd want to consider for that. The next thing we're going to want to look at after we get concurrency is adding caching. And I wanted to talk about caching because in a concurrent web application like this, it's important to understand the race flag, which I have a link to here, the article that talks about it, and how you want to avoid race conditions. But on top of that, it's nice to see how things like caching can actually have a bigger impact than concurrency, because a lot of people come to Go thinking, I really want to use their concurrency and stuff like that. But there are times where people will try to apply concurrency to a problem, and it's not that it's a bad idea to apply it, it's that things like caching that have been around for a long time can actually have a bigger impact, so you still want to stick with the tried and true tools that you probably know. So we're going to look at caching as well, and essentially what that means is after we look up all 30 stories, we don't want to do that again for a while. So maybe we'll have some timer, maybe it's 15 minutes. Every 15 minutes our cache gets reset, and we have to relook up the stories, but for 15 minutes, as long as we've looked up the stories once, every subsequent page request will just use that cached version. And this makes our site way, way faster, but obviously it has the downside of, it might be 15 minutes stale with some of the data. So as a bonus, I talk about some different stuff that I'm hopefully going to look at in some of these videos. The one is there are different ways to use Go routines and concurrency with this. One is to start up a Go routine to get every single story you're going to get. Another might be to use a worker pool of some sort and use something like a semaphore or channels to communicate with that worker pool. On top of that, you can also improve your cache in the sense that the first version of your cache will probably be something where you cache your results, and then in 15 minutes, if the results are invalid, you wait till the next web request comes, and whenever it does come, you reset, you say this cache is invalid, so you go actually retrieve all the stories and you re-update the cache. So what you could do instead of that is you could actually have, say your cache is valid for 15 minutes, you could have a background job of some sort that every 10 minutes goes and updates the cache. And that way your cache should realistically never actually become invalidated. And the easy way to do this is to kind of think of it as having two caches, let's say A and B. So if people are using cache A, you would go update cache B after 10 minutes, and then as soon as it's updated, you'd change your server to stop using cache A, to stop using cache A, and then to start using cache B. So you kind of swap back and forth between the two depending on which one's the most up to date. Aside from that, I do want to go back to the concurrency stuff just to talk about it for a second. The first version, you should just focus on, how do I get this working? Don't worry about being perfect. So don't worry about the stories being in the same order necessarily. If let's say you run it concurrently and you get 30, you retrieve 30 stories and 5 of them end up being job postings or discussions, so your page only renders 25, that's fine too. Just get this working first. Once you get it working, there are 2 different criteria here that you should try each one of these out and try them separately first. So the first is try to retain the story's original order. So with concurrency, there's no guarantee. So let's say I spin up a Go routine and I return, and I do this for 30 different stories. There's no guarantee that they're all going to get responses back in the order that we started the Go routines. So you want to figure out a way to keep track of the original order so that whenever you get results back, you can make sure they're still rendered in that same order that they would have been done if you had just done them one at a time sequentially. The next part is to make sure you always print out 30 and only 30 stories. So what I mean by this is, let's say you retrieve 30 and 5 of them are jobs or discussions. Look into ways to have your server figure out when this happens and start up new Go routines, or maybe use a worker pool, whatever you're doing, in order to make sure you get at least 30. And then once you're at 30, you can go ahead and render the page. And then finally, try to do both of these together. And I'm going to warn you now that each of these individually aren't, it's not that they're easy, but they're much easier individually than when you put the 2 together. So when you put the 2 together, you end up in this weird situation of Not only do I have to get more stories and I have to make sure I only get 25, but I also have to make sure that when the results come back that I'm putting them in the correct order. So it's going to be a little bit trickier, and that's actually why I chose this exercise, because I wanted to show you that concurrency doesn't always mean just adding Go routines. Sometimes you really have to think about your code, think about how you're designing things and how you're communicating stuff between different parts of your code. And I really just want you to get a chance of experimenting with that and getting a feel for different ways to tackle problems like this. So at this point, I think I've described this pretty thoroughly. I would say you can go ahead and read everything here. I need to probably add some more relevant links and stuff like that. But for now, just go ahead and read the exercise, start taking a stab at it. And before you even do that, you might want to look over the code here, because there is this, this code will render the page, and then there's also the template, which is the index.go HTML. And again, a really simple template, but it will render all the links that we have. And then in addition to that, I have this HN package, which is nested inside of the Quiet HN. And this is a really, really, really simple Hacker News client. So if you want to check that out, you can as well. You'll see here that I have an API base, which uses the Firebase API endpoint for Hacker News. I've got a client object, which doesn't really do much, or sorry, it's not that it doesn't do anything. It doesn't have a lot of fields or anything like that. It has this one unexported field API base, and you're probably wondering why that's there. So if you go to the tests, you'll see that I use the API base so that whenever I'm running my tests, I can actually set up a local server that I know is going to return some specific JSON, and then I can run my tests based off of that. So you're going to get to see how I've written a unit test here, or a couple unit tests here that stubs out that server with a local server so that I can test things easily without relying on the Hacker News API. And then I've also got this defaultify function, which is going to look a little bit funny, but when you read through the code, you'll notice that I do this so that the client, the zero value for it is useful. So that's something that you'll hear a lot of people talk about in Go, is make the zero value useful. And this is an unexported field. So one of the ways you could approach this is you could have a new client function that would set this whenever it built the client and then return the client. And that's fine and all, but if you want to make the zero value of client useful and this not to be empty, then having something like this defaultify function makes it really easy to, if it's not set to anything, then we can set it. Otherwise, if it's already set, so say it was set in a test or something like that, we don't have to worry about it. Lastly, there is an example of this, and this is mostly just here so that if you happen to run Go docs locally, you'll get to see this. I can actually probably do that. So if I go to localhost 3030, and then if I go here, so if you go to packages, you'll see here that you can actually navigate through all of this, but I just went ahead and just put this hard-coded in the URL here so that we didn't have to navigate through all of that. And this is the HN client that I was just showing you. And that example, you'll see here, since it's in my test file, it shows up here in the examples. And it's just a relatively simple example that shows you how to do it. The only reason I'm mentioning that now is, well, one, so you can just see this, I guess. But the other part is whenever you're looking at this, you're going to wonder, why didn't I just put this inside of the other test? And it's because this test here is part of the HN package because I need to be able to access unexported fields. But if you look back at this one right here is inside of a different package because I wanted the example to run from outside of the HN package. And there are other things I could have done to make this work. I just opted not to do that. I opted to instead, go ahead and set this up this way so that my tests that are unit tests can go ahead and interact with things that are unexported. But once I get to my exported stuff, once I'm working outside of the HN package, I can write an example much like an end user would. Okay, so I think that's everything. In the next video, I'll get into coding this. We'll look at concurrency, and I'm going to try to show you a couple different approaches to this. Some of these are not going to be good approaches, but I just want you to see, how you might approach the problem and how different approaches maybe do or don't work or why they're not so great. So I'm not going to try to just jump right into the best solution. I'm just going to sort of mess around, show you some different stuff, and we'll see what we get from there. As we jump into this code, the first thing I want to do is come up here and find the code that's used to get these stories. Because this is the code we're going to be changing, the code we're going to be trying to make concurrent, and really just changing how it all works. So I think it's a good place to start, especially with taking all this and just pulling it out. Specifically, all of this section is used to retrieve all these stories once we have a list of IDs. So we've got this part here. We could actually take all of this if we wanted, to be honest. So from here, we take all of this. We get the client, we get the IDs, we get the stories from those IDs, and then we eventually render the template. So if we pull this all out, even if we add concurrency to this, the rest of our code should be basically the same. As long as we get the stories back, we don't really care how they came about. So we're going to pull all that out, and I'm going to do a function, get top stories. And I don't know what this is going to take in or what it's going to return yet, so I'm just going to go ahead and just leave it blank, paste in our code, and then I'm going to go ahead and look at this and figure out what do I need to return. So looking this over, the first thing I see is this http.error. I could ask for W and other things like that, but I don't think that makes sense. I think instead what makes sense is to make sure that one of our return values is an error. So we're going to need something in an error. And then the second thing we need to return potentially are these stories, which is a slice of items. And this is like the primary thing we're trying to get here. I think if we take that, that should be most, I think that's most of the things we need here. So that should be our return values. Then we'll have to figure out what we need to accept. But for now, we can go through and refactor this code a little bit with this in mind. So this is going to be a return nil, errors.new. And we'll say failed to load top stories. Get rid of the rest of that. And then here we're going to get these stories. We're going to come down through all of this. If we get all of our stories, then at the very end, we're going to return stories, nil. All right, so that's get top stories. It looks like we're going to need this num stories. You can see here that it's got a line under it. It's erroring. So here we'll just put num stories, int. And that should, pull this all into a function. It's a good, quick, and easy way to refactor that. So now we're going to take this get top stories, and we're going to come up here. And I'm going to take all of this code and just replace it with stories, error, equals get top stories, num stories. And I'm going to say if there's an error, in this case, we're going to do http.error. And normally I would say you don't just want to print out the error message, but in this case, we just wrote it. We know the only error that returns is this errors.new, failed to load top stories. And there are other strategies to sort of figure out which errors you can expose to the user versus which you can't. In this case, I'm just going to go ahead and just expose it, knowing that I just wrote it, but potentially that could change down the road, so it's something you might want to keep in mind. And then http.status internal server error. And just to go back to that error comment I made, what I generally mean by that is I don't like taking random errors that I don't really know how they came about or any other information about them and giving them to the user. And I don't like this because sometimes you might give away sensitive information you weren't expecting. For instance, let's say you were trying to update a user's password and for some reason there was an error and that error message somehow had some sensitive information that you didn't want them to know, like maybe their ID, maybe information about what type of database you use, who knows, it could be anything. And you might not want to necessarily give that up to the user. So typically whenever I'm doing something like http.error or sending a message to the front end, I will make sure it's a curated message that I want the user to see. And if I don't know for sure that it is, I'll give a generic message like something went wrong. That doesn't mean you don't necessarily log the error internally. So that's how I generally see it myself, is I'd log it or do something else. But it just doesn't need to be something you necessarily give to the user. But anyway, getting back to what we're doing, assuming this all worked, our code should still work, but it's going to be slow still. So I'm going to go ahead and go run main.go. And this is not the page I want right now. This is the page I want. So I'm going to refresh this page, and you're going to see that we're still loading slow, 1.94 seconds. But it looks like it's getting most of these pages, and there's still 30 of them. So it looks like that refactor worked correctly. So the next thing we're going to do is we're going to look at adding concurrency. And I'm going to warn you now, this first thing we're going to do is not going to actually help us. But I just want to give it to you as an example to show you that adding concurrency is not just adding a Go routine. It's not just adding a Go routine in a channel to get your results back. It doesn't always just give you concurrency doing that. So sometimes you have to think about the problem. So the easiest thing to, the easiest mistake to sort of fall into here is to say, all right, I'm getting these items. So maybe I want to do something like a type result, which is a struct. And in the result, I'm going to get something like an item, or I'm going to get an error. So this is what's going to come back whenever I, call this client.getItem. So I know I need to know that information so that, whenever I run this in a Go routine, I can get the results back. So then we're going to say the result channel is going to be make a channel of results. And then here we'll go func. and it's going to take an ID, which is an integer. And if you don't understand why I'm accepting the ID here, I think I mentioned it in a previous thing, but basically this ID value is going to more than likely be changed as we iterate over this loop. I'm pretty sure it does for sure. So what we want to do here is we want to go ahead and make sure that we pass in a copy of it. So if I call this function here by putting this parenthesis here with the ID, it'll copy the value that's in ID whenever I'm creating this go routine, and it'll pass it in so that, I don't end up having this value overwritten to be, the same value every single time. And I feel like I explained that poorly, but if so, just reach out and I'll clarify a bit. Okay, so what we're going to do here is we're going to say if there's an error, we're going to send on result channel a result that says the error is error. Otherwise, on result channel, we're going to send a result that says the item is going to be parse hn item, and it's going to be hn item. And then we can get rid of that. So this right here is, we're doing this in a go routine now. You're going to see that it's not going to help us, but technically it is in a go routine. So after we have that, we want to go ahead and look for the results. So what we're going to say is result, so we want res is going to be equal to the result channel, whatever comes back from it. And this is going to be blocking. And this again is why that go routine is not going to matter, because we're only going to have one go routine running at any time, and then we're going to block immediately afterwards. So we're going to say if is storylink res.item, but we also need to check for errors. So we're going to say if res.errors not equal to error is not equal to nil. Then we're going to say continue. Otherwise, I think I got scrolled too far. Okay. Otherwise, if the is storylink res.item, then we're going to append this. So we want res.item. And then if the length of stories is greater than the number of stories, we're going to break. And I think that's everything we need here. All right. I believe that's it all. That's all of it. So, we're creating this type that is basically just the results of our go routine. We're creating a channel so that we can get the results back from that go routine. Then we are running the go routine. We are passing back results, whether or not they're an error or an item. And then we're going to go ahead and take this channel. And whenever we have an error, it's not nil, we're going to go ahead and continue. We don't want to use this one. But if it is a story link and, if we append and everything, then we're going to break out of this whole for loop. So we can go ahead and test this. So I've saved it. I'm going to go ahead and restart the server. I'm going to go back here. I'm going to refresh the page. And assuming I didn't make any major mistakes, you'll see here that our page still loaded. This time it was 3.2 seconds. It's generally going to be about the same speed. So that one just happened to be slow. This one was 1.78. So it's the same speed because, as I said, every time we spin up this go routine, we don't get a second go routine created before we immediately get to a blocking statement here. And this blocking statement is going to say, I need results from this go routine before I can move on. So it really doesn't matter that we're doing this in a go routine because we're still waiting for that go routine to finish to do anything else. But I did want to just show you this because it's a good starting point to get an idea for this, but also because it's an easy mistake to make. I've seen people code this mistake all the time where they're thinking I'm using go routines, but realistically it's just adding extra complexity to their code. It's not actually giving them performance gains. So in the next video, we're going to look at how to take this and turn it into actual concurrency. I'm going to stop this one here because I want to try to keep these videos a little bit shorter. But yeah, the next video is going to be taking this and adding actual concurrency. So we saw how this code doesn't work correctly, or it doesn't do exactly what we wanted it to do. It didn't actually give us any performance gains. So in this video, we're going to look at how to add actual concurrency. And to do that, we're going to have to look at what information are we going to lose by, taking this for loop that we have and losing the fact that we know the exact order things are going in. So that was a poor way to describe this. So what I mean here is we spin off a go routine and then we wait for the result. So if we were to just spin up, let's say 30 go routines, and then later on we were to go ahead and take all the results and bring them back in, what information is lost? Specifically, I think the biggest thing that's lost here is that the order gets lost. So right now we go through this for loop, and as we're going through it, we know that we're getting things back in the order that we iterated over them. But if we were to take this go routine and just sort of spin up 30 of them at the same time, we don't really know which ones are going to return first, which ones are going to maybe take a little bit longer parsing the URL, Who knows? So we don't really know for sure which ones are going to return first. The easiest way to figure that out is to add something to our result, like the index. And with that, we can actually say, all right, if we keep track of the index of each one as we queued them up, so, the first one would be index 0, then 1, then 2, at the very end, we can just take our results and sort them the way that we originally intended them to be. So now we have the order back, and we don't have to worry too much about which go routines come back first, because we can always retain that information. So to do this, I'm going to take this result type, and I'm actually just going to move it up here to the top. And then I'm going to do result channel is going to be make chan of results. So from here, I'm just going to go ahead and delete these two pieces. And this code is going to stay basically the same, except I'm going to come down here, and all of this code I'm going to copy, and I'm just going to move it down here and comment it out. Okay, so we have our result type, and it has an index, an item, and an error. We create the channel, and then we're going to go through all of our IDs, and I'm actually going to change this to be index, comma, ID in the range of IDs. And then here, I'm going to pass in the index and the ID. And index and ID, obviously these look like similar variables, so if you want to change them, feel free to. So from here, we get the item just like we would. We use the ID. The only thing that really changes here is the results we're sending back. So rather than just an error and just an item, we want to always have the index, which is going to be something like this, IDX, IDX. So all of these results will always have that index associated with them. So from here, the next thing we want to do is consolidate these results. So we know that we're spinning up, a bunch of go routines here. So once that's done, we want to go ahead and, use something to collect them all. The easiest way, in my opinion, is to create something like a result slice. And this is just going to be a place where we take everything that's coming in from result channel. We're going to stick it in the slice. And then once we know we have all the things that we actually created, we're going to go ahead and sort it so that we can get it back to the order we wanted it in. Well, if you look at this up here, I am going to stop us for a second. The range of IDs it's probably not obviously this to you right now, but if I go up to HN, if I go to the client here, the URL used is /topstories.json, but it's this right here. And if I go topstories.json, I'm going to show you this because there's a lot of stories here. If I recall, last time I checked, it's like in the ballpark of 400, 500, and we really don't want to spin up go routines for 400 or 500 stories. It would just be a complete waste. We don't need to look up that many stories. So what we're going to actually do here is I'm going to come back to our main.go. And rather than doing all of the IDs here, what I'm actually going to do is say for index is equal to 0, index, actually I'm going to call this I. For I is equal to 0, I is less than stories, I++. So I'm only going to do this for, however many stories we need, we're going to do that. And I know that that's going to break that assumption that we need at minimum 30 stories. So basically, if any of these stories get filtered, we're going to have a little bit less. But I think that's fine for now. Right now, we're just focused on using concurrency and trying to keep the results in the same order. Later on, we'll look at ways to, make sure we keep as many as we need. But for now, I'm just going to start with just this part. So we need to pass in these values. Again, these changed. So this is going to become I, and this is going to be IDs, I. Okay, so that should be all of that. Now what we want to do is we want to go ahead and say for I is equal to 0, I is less than num stories, I++. And this is another upside to having a fixed number. We know exactly how many things we started go routines for. So now when we go to read the results, we know exactly how many results we expect to get back. So in here, we can actually say results equals append results, and we can take the value from result channel, and that should give us all these results back. So now that we have all the results, the next thing we want to do is we want to sort them. So we want to go ahead and say, how do we take all of these results we have and sort them by their index? Well, the easiest way to do this is the sort package. So we're going to say sort.slice, and this takes in a slice, which is going to be our results. And that's the slice that we created right up here. And then the next part is the less function, which basically says, if I give you two indexes, I and j, can you tell me if the thing at index I is less than the thing at index j? And then it can sort based off of this. So we're going to go ahead and say func I, j, which are both integers, are going to return a bool. And then in this, what we're going to say is return results I dot idx is less than results j dot idx. So we're just going to say that if the whatever's it currently in results at index I, if its idx has a value less than the whatever's at index j, then it's less. And that will end up sorting these from index 0 all the way up to index 30 or whatever index that we're using. Okay, so the next thing is to take all these results and filter out the ones that we no longer need. So things that are errors, things that aren't a story with a link, any of that type of work we're going to go ahead and do next. So we're going to say var stories is going to be a slice of items. Then we're going to say for each result in the range of results. And I'm using res here instead of result because the word result is actually the type that we're using. That's actually one of the reasons why sometimes in my mains you'll see me use a capital letter for a type. It's just because it's sometimes a little bit easier as far as like naming your variables and stuff like that. Okay, so here what we want to do is if res.error is not equal to nil, continue. We're just going to go ahead and skip anything that has an error. And we're going to say if is story link res.item. And then if that's the case, we're going to say stories equals append stories res.item. And you'll notice here that we don't need to add a break or anything like that because we know that at most we have, At most we have num stories items added to our result slice. So as we iterate through this result slice, we can't ever add too many stories. If anything, we'll just have too few. So we're going to go ahead and do all that, and then we're going to return stories, nil. And we can get rid of everything down here. Okay, so assuming that all worked, we should be able to go run main.go, come back here, and I don't need this page, I need this one. Refresh the page. So the order looks to be about the same. We have less things here, but the order looks to be about the same from what I can tell. And if you look at the time, you'll see that this is 624 milliseconds now instead of 1.7 or 1.9 seconds that we had before. And obviously your times are going to vary based on your internet. You'll also see sometimes we're getting slower times, but sometimes we get faster times. It really just depends. But we do have concurrency here, and it does seem to, overall be speeding this up a little bit. So now that we have the concurrency working, I'm going to go ahead and end this video. We're going to go ahead and still continue to tweak this. I think the next thing we're going to look at is how do we ensure that we always get 30 stories? So if you see here, apparently there were 3 things that were either jobs or discussions. So our list ended up getting smaller. And, this is something that's sometimes a little bit tricky to test because Hacker News doesn't always have jobs or discussions on the front page. So you don't necessarily know for sure that that's going to be the case. And that's where testing and, writing tests like that can be really helpful. But for the time being, we happen to get lucky enough to have some here. So that should really help us as we write this code. So the next thing we want to do is make sure that we always get 30 stories. And I think this is worth just discussing a couple different potential strategies here so that we, at least evaluate them all and figure out which one makes the most sense for us. So the first one is to just spin up the Go routines for all the IDs like we saw initially, where we almost did is what I should say. Let me go look for the code. Here we only do it for number of stories. One option is just to crank that up to however many IDs we have, just do it for all of them, and then take the results and do whatever with them. So obviously this is a huge waste. It could slow down our application, and the whole point of adding this concurrency was to speed things up, so that might not make a lot of sense. Another option is to find some reasonable number that we think will get us enough stories that even with discussions and jobs, we'll still have 30. So say, for instance, we're looking for num stories as 30. Maybe we'd say we want is going to be num stories times 1.25 or something like this. And then we can go ahead and use that number throughout the rest of our code. And, we know we're going to get a little bit extra, but that should be enough that gets us through, so it at least gets us 30 stories. So before I move on, an easier way to do this is times 5 divided by 4, just because it's the same as 1.25, but we've got all integers here, so you shouldn't run into, things getting truncated down to like a 1. But anyway, so you could use that throughout the rest of your code. And as you're actually doing this, you'll see that most of the time this will work fine. You might get like 33 stories back. You could filter that down to 30, just the top 30, and for the most part you'll be good. But there's always that small chance that it's a really, maybe it's a really busy day for discussions and it doesn't work all the time. So while I think it's a good option most of the time, and if you were just looking for something quick, this is definitely where I would start. But it doesn't work all the time, and since these are exercises that are sort of intended to teach you different things, I think it's important to look at how do we guarantee that we always have 30 stories. So the next thing I would say is the third option is get however many stories we're going to try to get, and then see how many we actually ended up with, how many got filtered out versus how many we got we retained, and then go get new stories. So maybe we get 30 stories, and if we only get 27 back, we go get the next 30 IDs, and as long as we end up with 30 at some point, we're good. Now, obviously, there's still a chance that we could go through all these IDs and still not have 30 stories, but we're not going to worry about that because there's not much we can do there. So that's also another option, and I guess a final option would be to sort of merge those last two options I discussed. So we could do something like this want, where we get a few extras, because we know that it's pretty likely there's going to be at least one discussion or one job, so we should probably get a couple extras every single time. And then another thing we could do is anytime we don't have enough stories, even if we use this strategy and we don't have enough, the next thing we could say is, let's go ahead and get some extra stories based on how many we need left. So to do this, I think the easiest way to do it is to first take this code we have and to go ahead and I think it makes sense to pull this all into a function. So I'm looking at this part here. So all of this code where we have the results, we go through the channels and we do all that. I'm going to take all that and delete it from here. And then I'm going to do func get stories. And I'm actually going to have this taken a slice of IDs, and it's going to return a slice of items. I don't think this can return errors because the only error we were returning from get top stories was this failed to load top stories. If we ever get another error, we've just been skipping the story for now, which I think is fine for what we're doing. We don't need the whole entire page to crash if one story just doesn't work. Now, if we added caching, maybe it would make more sense to figure out why it happened or maybe retry. But for the time being, I think it's fine just to skip it. Okay, so I pasted all that code I had in here. And what I'm going to do here is I'm going to change this a little bit to instead, we're not going to do the one thing just yet. But what we're going to do here is we're going to say for I is 0, I is less than the length of IDs, I++. Then I'm going to come down here and do the same thing, length of IDs, I++. Look at the rest of this code, and we're going to return stories. So you'll see that I didn't have to change much. All this code really does, we're going to need a client though. So I'm going to go up here and just do var client hn.client. So all we really did here was we took all of this code we used to get the stories based on a slice of IDs, and we just went ahead and set it so you're going to use the full ID slice and just return as many as you can from that. So what that means we can do up here is we can say stories is going to be get stories, and then we could do something like IDs 0 to num stories. And this should be exactly the same as our code was before, but the upside is we can now reuse this get stories much more easily. So what we're going to do is we're going to say we're going to say var stories, which is going to be a slice of items, for the length of stories is less than num stories. And then here what we're going to go ahead and say is we want to get more stories every single time this is true. But I'm going to start up here and say at is 0. So this is going to be the index we're starting at in this ID slice. And then in here we're going to say we need num stories minus length of stories. So this is how many stories we need left. So if stories is currently at like 0, num stories is at 30, this will be 30. But if, say we went through and we called this function once and we got 10 stories, then this would end up being a 20 because it's saying, all right, we need 20 more stories still. So once we know how many we need, what we're going to do is we're going to say stories is going to be append stories, get stories, and we're going to pass in IDs from at, which is whatever index we're starting at, all the way to at plus need. And there's a chance here when you look at this that either of these two could exceed the bounds of our index or of our slice. I'm not going to worry about that for just this second, but it is something that if you were doing a large enough num stories number, you would need to take into consideration. And then we need ... here because append expects this last part to be a variadic parameter. And then finally, at is going to become need. So at's going to be plus equals need. So what we're saying here is that if need is 30 and at is 0, we're going to pass in IDs 0 to 30. So we're getting like a subslice of our slice. And then we're going to go ahead and say at equals 30 so that in the future we would do something like IDs 30 to maybe 35 or something if we needed a couple more. So this is how we're sort of making sure we don't continuously get the same stories over and over again. So with that, this didn't do both the parts we mentioned. This is only the last part where we're just guaranteeing we get enough stories. And we're just going to get more stories every time we don't have quite enough. So we're going to go ahead and save this and just give it a test run, assuming I coded everything correctly. And you'll see that we now have, as many stories as we were expecting. It looks like we still have the same top story. It looks like they're all in the correct order. You could actually bring up the Hacker News site if you really wanted to compare these. And you'll see that, the first question here is an Ask HN, which is just a discussion. And that's actually why we're not seeing it in our Quiet Hacker News, because, we're filtering out those discussions. Okay, so now we've got 30. I think the next thing we want to do, and I'm not doing this in a separate video because it's fairly simple, is basically say that anytime we are going to go ahead and get some stories, we want to make sure that we don't get, we don't just want to get exactly how many we need, because there's a good chance that in that set, one of them could be a discussion. So I think we can add a couple extra stories here. And the easiest way, I think, to do it is to do something like num stories minus length. So this will get us a number like 30. We're going to say times 5 divided by 4. And I put the parentheses around this whole section because I want this to be evaluated first. And then multiply it by 5 divided by 4 is the same as times 1.25. But since we're using integers here, it should, avoid any sort of integer issues. And we don't have to mess with floats at that point. Okay. So assuming this is all working, one of the things we could do here actually is we'll just put loop here. And I'm actually going to get rid of this part. Actually, I'm going to comment it out just so we can use it again. So let me stop the server, restart it. I want you to see if I refresh this page, you'll see that loop got printed 1, 2, 3, 4, 5. I'm not sure why it was printed quite that many times, but that's okay. Actually, I think one was probably a favicon request, but that's whatever. We'll let that be. So looking here, you'll see here that it looks like it loaded that a couple extra times. But if we take this, put it back, and restart our server, we should see less calls to that loop. And as you can see, we're getting actually a couple extra stories, which I'll discuss here in a second. But looking at our code, we've only got 2 loops here. And if you're unaware of what I meant by the favicon, when you visit a page, a lot of the times your browser will also request something like favicon.ico or something like that afterwards, which is this little icon at the top of the browser. So my server is actually set up right now that whenever it requests that, for any web request, it always returns this HTML page, which is obviously not what we want for the favicon, but it's fine for the time being. Okay, so we've got this getting a little bit extras. Now the last thing we want to do is make sure we don't return too many extras. So we're going to say we want to return stories from 0, and we don't need the 0 actually, we can just put the colon, to num stories. So stop our server, restart it, come back here, refresh, and now we have exactly 30 stories. And again, you'll see that our page is loading relatively quickly every single time. We should only usually be doing 1 loop to get all these stories, because if we're requesting 30 times 5 is 150 divided by 4, we should be in the ballpark of, I think, like 37. Is that right? 30 times 1.25 is, 37. So we should be getting something like 37 different stories. And, it's unlikely we're going to find 7 discussions or jobs at any given time. So it's usually one loop through that whole get stories call will get us all the stories we need. So I'm going to delete this print line. And from here, we have both the parts that we talked about with concurrency. So I happen to just end up coding them both in the way that they both work together. But it's very possible that if you wanted to do the the part where you guarantee you have 30 stories, that you might have written it a little bit differently. You might have forgotten about the index part. The two of them can sometimes be a little bit tricky to put together. That's why I had the notes in the in the description, and I also mentioned it in the intro video that sometimes when you try to do both concurrently, getting all the stories and making sure you get 30 and keeping the order, like all those things can be tricky. And it's okay if you didn't get it perfect the first time. It takes a little bit of thought to get that all right. So that's it for this right now. Eventually, I want to do some bonus videos. I'll try to get them done once I get the caching up. Next is going to be caching. And then after that, we'll look at the bonus videos, which I think I mentioned before were caching with, two different caches that you can sort of update each one while the other one's being used. And then the second is using a worker pool. So right now, if you look at this code, we currently just spin up a Go routine for every single, item we're going to get from the API. But it might make more sense to maybe have, limit this. Maybe we only want 5 web requests going on at the same time, because if we get too many, it really bogs down our traffic, and trying to switch between all these requests just slows down our computer. So there are different times where maybe you just want to go ahead and limit that to some number like 5 or 6 or 10, or I don't know what the exact number is. It depends on your application. But you can actually set this so that, or we could code this so that we're using, a limited number of Go routines, but we're still using concurrency to solve this problem. And I'll look at those in the bonus exercises so you can really see how to sort of do that. Next up is adding caching, but before we do that, I want to talk about the race flag. And specifically, I want to go ahead and show you how to use it and check our application for any race conditions first, because as we go to add this cache, I'm going to intentionally add a cache that has a race condition. And then once I know I have the cache with the race condition, I'm going to show you how we detect it with the race flag. But before doing this all, it's important to know that our application doesn't already have race conditions, because if it does, we might think that there's something wrong with our new caching code, but in reality, there's already a race condition there. So looking at our code, the big reason why I think this is important to check, also just before we jump to the race flag, is that whenever you do http.listen and serve, this actually starts a Go server. The standard library does that for you, but the server will actually take all the incoming requests and split them each into Go routines. So whenever you start to access different variables and different pieces of information, there's already different Go routines running. So it's actually not that hard to write a web application that has a race condition without realizing it. So again, it's just something you should probably get in the habit of checking with your applications, especially web servers, to try to make sure you don't fall into this trap. So for us, we're going to go ahead and do go run. You can do go run -race and then put the main.go. So this will work. The other thing you can do is go build -race main.go, and then this will create a binary, and that binary is going to be, it's going to be the same as any other binary that you can run, but it'll already have the race flag built into it, so it'll actually print out if it detects a race condition. So I'm going to do go run -race main.go. I'm going to come back here, and I'm actually just going to refresh this page many different times. I'm just spamming the refresh button, which is Command R in Mac. And I'm doing this because I wanted to do multiple requests at the same time. I'm trying to simulate having many users hit at the same time. And this is a poor poor approximation, but it should give us a rough idea. Okay, so I've done that. I open up my terminal, and you'll see here that we clearly have something going on. Well, it looks like it's a race condition. And if you dig further into this, here is going to sort of tell us where it's going wrong. So we've got read at Go routine 88, previous write at this by Go routine 87. And these are both coming from the HN package that we didn't actually write as part of this exercise. It was just already there. So let's go there and figure out what's going on. So this is client.go 24. So if I open this up, you'll notice that line 24, and if I open up the other one, I think it's line 23. Yes, it is. These two lines, what's happening is that we've got multiple Go routines that are trying to use the same, probably using the same client here. And what's happening is that every single time that they come into this, one Go routine's checking to see if this is empty, while another Go routine's trying to set it to a new value. So basically, there's a small chance that this could cause you issues, especially if you're changing this value or you're deleting it at certain times, or if something different is going on. But in our case, it's unlikely that this is going to cause issues, but I'd still like to get rid of it. So what I'm going to go ahead and do is come back here, and I'm going to go ahead and inside of our main.go, I'm going to figure out where was this happening. and it looks like it's in main.go line 79. So if I go to line 79, and it's going to be inside of this Go routine, the one where we actually call client.getItem, that's where we're having this issue. So let's just imagine that our client was not thread safe. It's not something that can be used in multiple Go routines. How would we fix this? Well, the easiest fix is just to take this client up here and put it inside of our Go routine. We're just going to create a new client for every single Go routine. And that seems really inefficient, but if you come back here and look, the client's really simple. We're not doing a whole lot to set this up, so it really actually shouldn't be too terrible. And, we should be able to go from there, and hopefully it'll work well for us. So what we're going to do is we're going to go ahead and clear the screen, and I'm going to go run with race again, and I'm going to come back, and I'm just going to spam refresh some more to see if that race condition is fixed. Now, usually you should actually figure out the real reason the race condition was there and really understand it so you know it's fixed for sure. But in this condition, or in this case, I actually know that was what was going on. So I'm just going to refresh to show you, all right, it doesn't look like that race condition exists anymore because it's not popping up. So now we're going to come back to our application and we're race condition free. So it's time to add our cache. To add the cache, we kind of got to figure out where it makes the most sense to add it. So I think the best place to add the cache is some sort of wrapper on top of get top stories. So if you look at this, this is the first place where we actually call a function that's, up here in the handler, we call get top stories, but aside from that, we don't really have a whole lot of logic around the stories, around how we retrieve them or anything else. It just calls this function, expects it to handle it all. So I think it makes sense to take this get top stories, which we know always uses a client, and to wrap it with something like func get cached stories, num stories, int. And again, the naming of this might not be the best, but since this is a small application, it's pretty clear, I think, what they're doing. People might think they can get more stories or whatever. This actually isn't going to take num stories into consideration, is what I'm trying to get at. It's going to assume that num stories that you pass in is relatively fixed throughout the entire process of running this. So if the cache only has 20 things and you passed in 30 here, right now our code's not going to invalidate the cache and it's not going to go get more stories. So now that we have this all set, or this written, we want to figure out how it works. So the first thing we're going to do is we're going to say stories, air is going to be get top stories with num stories. If the air is not equal to nil, return nil, air. And then we're going to say return stories, nil. And you're probably wondering, why don't we just return stories and air? And you'll see in a minute, whenever we go to do the caching stuff, why that might make sense. Okay. So the next thing we want to do is figure out a cache. So what is our cache going to be? Actually, let me take that back. I'm going to take this get cache stories function. I'm going to go ahead and make sure we call it up here so that we're actually using the new code. So for our cache, I'm going to actually just start with a global variable. And then long term in one of the bonus exercises, we'll look at how to pull this out of a global variable. But I'm going to start here for now. So our cache is going to be a slice of items. And then we need to know when our cache has expired. So whenever this value in the cache is no longer good and we need to make more API calls to fill it up again. So we're going to say cache expiration is a time.time. Then coming back down here, we're going to say if the cache is not expired, and I know this isn't valid code, I'm going to leave this blank for now. So if the cache is not expired, we're going to return the cache and nil for the error. So we're just going to skip all of this code if our cache is good. And if our cache is not good, we're going to come down to this code and we're going to come down to this part right here and we're going to say if we got the story successfully, well, now we can say the cache is equal to stories, and then we can say the cache expiration is equal to time.now.add, and then we want to add some sort of duration for the cache. So normally this would be something like 5 times time.minute, or maybe it's 15 minutes, whatever you think makes sense. But for now, I'm going to actually leave this at 1 times time.second so that our cache is expiring very quickly so that we can test it for race conditions. And then at the end of this, we're going to return the cache. Okay, so now we need to figure out how do we do the cache is not expired. Well, the easiest way for me with times is to think about this is if the current time, if now is equal to 1:15 and the cache expires at 1:20, looking at these, what do we want to know to say the cache is good? So we want now to be less than expired is what this looks like. So as long as the current time is less than the expiration date, we're good. Well, what that would look like in code is something like time.now is less than cache expiration. So we'll comment this all out. But unfortunately, this doesn't work in Go because times aren't something that you can use this less than operator on. So rather than trying to do this, the next thing we're going to look at is how can we sort of take the times we have and figure out, is this a good, is this cache good? Well, time does have, if I can find it here it is. It does have this subtract and this add method. And both of these will return a duration, which is, the duration between the two times. So if you have a time.sub time b, it's going to be the duration from a minus b. So looking at this, durations are int64s behind the scenes, down here at this point. So that actually means we can use things like less than and stuff like that on the duration because it's basically just a number like we normally use. So looking at this, if we did 115 minus expiration, which is 120, we get something like negative 0.5. So negative 5 minutes is what we're going to probably get back. And, looking at, it's going to be in an integer, it's going to be in the time.duration value here, but it's actually going to represent something like negative 5 minutes. So knowing that, what we can actually do here is we can say time.now.sub cache expiration. And if this is less than 0, well, then that means that our cache is valid. So it's a weird roundabout way to get there, but you'll get used to it at some point, I promise. So what we're going to do here is we're going to say time.now, subtract the expiration, and if it's less than 0, then our cache is good. And if you're ever wondering how to sort of translate this quicker, the simple way is if you want now is less than, x or whatever, you can do now.sub x is less than 0. So, it's basically the same order of these two. The less than stays the same. It's the same if you wanted greater than here. You just make this greater than 0. And, the two are really easy. Okay, so we've got all this. We've got our cache. We want to go ahead and see if this works with if it has a race condition, but we also want to see if it works. So I'm going to make this 15 seconds. And before we even check for the race condition, I'm just going to go ahead and make sure it works. Come back here, look at our page, refresh. So the first load, took 700 milliseconds, but you'll notice that subsequent loads within the, the 15-second time limit are much, much faster. These are nanoseconds instead of milliseconds. And that's really cool because it kind of shows that even though we went through all that trouble to add concurrency and all these things, caching is having a much, much bigger impact than doing the concurrency did. So, it's something to keep in mind as you build stuff like this, that really simple things like caching, and even though they might get you slightly outdated data, is it really a big deal if, say, the comments on your blog are out of date by 5 minutes or out of date by 2 minutes, or maybe there's different ways you can look at that and figure out, how do we make this correct while also being really fast? And in this case, I think, this is a slow web request because our cache was invalid, but if we refresh now, it's a really, really fast page. So, it's kind of nice to have that really speedy page rather than making people wait 1 or 2 seconds to get those stories. So we've got all this working. I'm going to go ahead and change this down to 1 second now. I'm going to stop this, restart it. Give me 1 second. Okay, so we've got this running. So I'm going to restart the server, and I'm going to go ahead and look for race conditions now. So I'm just spamming reload again like I was before. So opening this up, it looks like we have a race condition. So now our next goal is to figure out what this race condition is and how we can fix it. So we're going to do that in the next video. I'm going to go ahead and just commit this code. And in the next video, we're going to look at, all right, now that we have a race condition, how do we use something to sort of prevent that from happening? And then in the third video, we're going to look at one of the bonus exercises, taking our cache and turning it into something that we can rotate between two different caches to really just eliminate that ever having that really low or really slow reload. In the last video, we saw how to add this cache when this is a cache with a race condition, but we saw how to add it. So in this video, we're going to look at how do we take that race condition and get rid of it. So we're going to go ahead and we're going to come back to here. I'm actually going to show you this mutex. So I'm going to go by example now instead of the standard docs or whatever, but you can find different information. Actually, let me just go ahead into the standard docs, sync Golang. And you'll see that I think it was part of the tour of Go as well. So the sync package has this thing called a mutex, and a mutex is a mutual exclusion lock. So essentially what that means is that it's a lock that if different Go routines are trying to access it, one of them will call lock, and then at that point, any other one that calls lock will have to sit there and wait until the mutex is available again. So they'll have to wait until something, whatever has the lock, calls unlock. So using this is actually pretty simple. What we'd end up doing is we'd say we're going to create a cache mutex, which is a sync.mutex. And then right here, we're going to say cache mutex.lock. And then we're going to defer cache mutex.unlock. And I'm going to go ahead and just warn you right now, when you're using a mutex, especially in code like this, I definitely recommend trying to defer the unlock, because it's really easy to forget to unlock it in a case like this, in which case your entire application freezes up. So say you forgot to unlock it right here in this situation, and now all of a sudden it never unlocks and your entire application just blocks at this point every time. So by not doing this, by doing it as a deferred call, we guarantee that whenever this get cache stories function exits, regardless of how it exits, this mutex gets unlocked. And now that we have this lock, what's going to happen is, let's say 2 web requests come in, and they both are trying to update this cache because it's expired. Well, the first one will get the mutex lock as soon as it gets into this function, and then it's going to go ahead and say if the cache is expired. Well, the cache is expired because, this stuff isn't true. So then it's going to come down here, and basically what's going to happen is it's going to update the cache, and then it's going to return the cache, and then this mutex will unlock. Well, then the other routine that was blocking, the one that was running at the same time, but it ran into this lock. So since the first Go routine actually got the lock, the second one would just sit there and wait. It'd say, all right, I need to wait for this mutex to unlock. Well, as soon as it gets unlocked by this deferred from the first Go routine, the second one will then start running through all this code, except for it, the cache is now going to be valid because the first Go routine would have filled up the cache with the valid stories and set the expiration to some time in the future. So inadvertently, by adding this cache mutex, we're actually going to be preventing our application from calling get top stories too many times. So while it was unlikely we would have had a major issue from that race condition, it wasn't one that, it wasn't the same ones where 2 different things are trying to read somebody's bank account balance and maybe manipulate it at the same time, which could be really, really bad. In ours, it's unlikely that the data we're setting in the cache is much different from one second to the other on Hacker News. So it wasn't a huge deal, but now we can eliminate a bunch of extra API calls, and our web requests will still be the same speed for the most part, if 2 come in at the same time, but we won't be doing all the API calls. So let's go ahead and see this in action. I'm going to change this to, we'll leave it at 1 second actually, because I want to make sure that we don't have a race condition. So I'm going to go ahead and start this up. Come back to our application. I'm just going to refresh a whole bunch like I was before. I'm just trying to figure out if there's a race condition, if we'll catch it. So I've refreshed a bunch. Open this up, and you'll see it looks like we don't have this anymore. So I'm pretty sure this mutex, solved that issue for us, and it's gotten rid of the whole caching issue, or the whole issue where we had that race condition. So the next video, after this one, what we're going to do is we're going to take this mutex and this cache, and we're going to try to create a type that contains all of this stuff. And the reason we're going to do this is that by creating a type, we should then be able to take one of the bonus exercises, and the one that basically where I talked about getting a rotating cache. So if we put this all inside of a type, we should be able to pretty easily switch which cache type we're using, so that, as our web requests are used, we can very easily switch between 2 caches without actually making people wait. And this is a poor explanation. Let me just show you what I mean. It's going to be much easier. So, say we refresh the page and the cache is expired. It takes 400 milliseconds. Refresh again. Every time we, it's much quicker. You'll see we got like 300 milliseconds or more when it has to refresh the cache. But if I come back here and let's say I make this 15 seconds, restart. 600 milliseconds the first time again, but now we're down here into these I don't know if that's microseconds. I think that's what that is. So we got microseconds here, which is much, much faster. And, we're only using like 2 microseconds versus, the 300 milliseconds, 400 milliseconds. So this is definitely way faster, but whenever our cache is invalid, we get back to this 300 millisecond time. And we really don't want that to ever happen. So what we'd love to happen is that, that happens in the background before our cache is invalid. So we're going to look at how to do that. And that's why we're going to be taking all of this and pushing it into a cache type. But that will be in the next video. For now, I'm just going to go ahead and change this. So the cache is good for, let's say 5 minutes. I think that's a good enough time to start with. And we'll make our cache, whenever we have our cache rotating, we'll have it like maybe every 4 minutes, it'll go ahead and rotate the cache. For our first bonus video, bonus exercise video, what I want to do is I want to look at this cache here, and I want to look at how we can change it so that we never have that slow load. So right now you'll see if I go run main.go, come back to our page and reload it, you'll see that we always have that really slow first load. Now we might have a couple quick loads after that, but we always have a first slow load. And on top of that, at some point we're going to have another slow load whenever our cache expires. So, it might be 5 minutes, it might be 5 seconds, it depends on this part here. But at some point we're eventually going to have the cache expiring, and the first person to load that is going to have that real slow thing. So what we're going to try to do is, 1, to populate this cache as soon as our server starts up, so that the very first page request, even if it comes pretty quickly, we'll have a cached value of it. The second is we're going to try to update our cache so that we're trying to keep our cache updated even, before a user makes a request. So let's say our cache expires every 5 minutes. One way to do this would be to say, all right, every 5 minutes our cache expires. So if every 4 minutes we go off and we try to reload the, the stories, and then we update our cache with those results, well then the user, if we're doing that behind the scenes, not for a web request, just sort of in a Go routine of our own, then the user should never actually see that delay because we've got a whole minute to get those results and update our cache before the user would ever notice the difference. So what I'm going to go ahead and show you is how to do the 2 of those in this bonus video. And, it's going to be a little bit different than how I described it in the README. In the README, I kind of described it as having like 2 different caches and rotating between them. And that can work as well. I'm choosing to do it this way because we already have a mutex, or we're going to have a mutex already built into our cache, and it's easier, in my opinion, to do it that way. But you'll see that, well, actually, I can probably do it both ways, so we'll go ahead and see what makes the most sense. Okay, so to do this, we're going to start off with a type. It's going to be type story cache, and it's going to be a struct, and we're going to have cache A. I'm going to do it the same as the README. I think that makes more sense. We're going to have cache A and cache B. These are both slices of items. And then we're going to have A or B. Actually, yeah, I think that's fine. A or B is going to be we're just going to make this use A. It's a Boolean. So if this is true, we're using cache A. If it's false, we're using cache B. Just trying to keep this as simple as possible right now. Next, we're going to have an expiration, which is a time.time. And next we're going to have a duration, which is a time.duration. This is how long the cache is good for. And then finally we're going to have a mutex, which is a sync.mutex. I think that's all we need. So now I'm going to go ahead and take all of this, everything inside of the get cache stories, and I'm going to put it inside of a method on our story cache. And I'm going to use a pointer to the story cache. So one thing to keep in mind here is the sync.mutex is not a pointer. I'm doing this so that when I create my story cache, it gets a default value and I can use it. But that means that if I were to copy the story cache, that this would also get copied. And, if I passed it by value instead of, passing in a pointer. And the downside to that is that, when the mutex gets cloned, it's no longer going to work as we expect a mutex to work because there's 2 different mutexes now. So we want to make sure that, one way to do this is to make this a pointer, and then to make sure that we initialize this when we set up our code. It might be an easier way to do it. Another is to make sure that we always pass the story cache as a pointer, so then we always have the same mutex inside. So I'm going to take that second option, is my story cache is always going to be passed as a pointer here. So inside of here, I'm going to paste all this code, and we need to do sc.mutex. So you're going to see that a lot of this is going to get changed. I'm actually going to come down here and just delete all this code that I have because I want to start seeing errors so I know what to fix. This is going to be called stories. It's going to return a slice of items or an error. Forgot to give my method a name. Okay, so we need an expiration, which is going to be sc.expiration. We need sc. So here this needs to change. So we're going to say if sc.use a, return sc.cache a, comma nil, else return sc.cache b, comma nil. And I could change this a little bit. I could, add a method on the story cache that just returns the correct cache. Maybe that makes the most sense. We'll do that. But the problem with that is that you kind of want to, you want to make sure this is done inside of a lock. And we could say that this method needs to be called whenever the story cache is already locked, but it might just turn into an issue. So what I'm just going to do is I'm just going to go ahead and put this all inside of here. So I know it's inside of the lock, and it's not really a ton of code, so I think it's fine just to go ahead and put it here. All right, so we do all this, and then the next thing we're going to do is come down here, and we're going to say if sc.use a, sc.cache a equals stories. And down here, we're going to go ahead and say, gotta move this duration part up. Say sc.expiration is equal to that. We want to add sc.duration here. And apparently num stories is something we want to keep account of. So let's do num stories int. And here we'll just do sc.num stories. This will mean else sc.cache b equals stories. And then finally, we're going to return and I'm going to fix this all up here in a second, but I'm trying to just get this so you can see how it works conceptually, and then we're going to clean this code up. So right now we're always using cache. This is going to default to false, I assume, so we're always going to use cache B. But regardless, it shouldn't matter. We're always just going to use one of those caches. So I could actually make this use B, but that's fine. So right now, I just want to make sure this works. So I'm going to go ahead and take all what we have, story cache, and I'm going to come up here and I'm going to create it. And I'm going to do it outside of this function here. I'm going to put it up here because if I put it inside of here, it's going to get recreated every time there's a web request, and I don't want that. I want to reuse the same cache across many web requests. So I'm going to say sc is going to be story cache, num stories, going to be the number of stories. What else do we need to set here? We need a duration. We'll make it 3 seconds for now. And do we need anything else? I don't think anything else needs to be set right now. So then down here, we're going to change this to st.stories, and this doesn't actually need any arguments. All right, I think that's everything. So let's go ahead and go run. We're going to run it with the race flag. I think it's important to use that throughout all of this exercise now. All right, first load is slow, all the rest are fast. Eventually we hit a slow load again, keep running. And I'm just going to go ahead and just keep refreshing a bit, try to check and see if there's a race condition of any sort. Doesn't seem to be one though. Okay, no race conditions. Everything seems to be doing good. So now we want to do the rotations. So how do we do that? Well, what I'm going to do is up here, I'm going to create a go routine that's basically going to do the opposite of what's going on here inside of this. So I want to go ahead and say if, where do we have it here? What I'm going to do is I'm going to write some code that says if, if the lock is, or how do I put this? Basically, I'm going to say, let's say our duration is 10 seconds, or I'm going to make it 6 seconds for the time being. I want to have a function that I'm going to run in a go routine, and it's going to say we're going to need a timer. So it's time.new timer. Oh, or ticker. Ticker was actually better. And the duration is going to be, let's say, 3 times time.second. So what I'm going to say is every 3 seconds, this timer is going to go off. When this timer, actually I want it to be a ticker. So let me change the name. So when this ticker goes off, I'm going to go ahead and say, I want to update my story cache. I want it to have a new value. So the easiest way to do this is to just go populate whatever I think the cache should be, and then to go set the values inside of the story cache. So this function doesn't really handle that right now. It always just uses one or the other. So I'm just going to show you a simpler way to do it, I guess. So we're going to say for, inside of our for loop, we're going to wait for the ticker.c to send us a message. So every 3 seconds, this will block, and then it'll eventually get a message from this channel, and it'll go ahead and continue through. We're going to say temp is going to be story cache, and the number stories are going to be num stories. Duration is going to be 6 times time.second. And then everything else, it's going to be the same as the story cache. Then we're going to do temp.stories. So this right here should, if it works correctly, it should lock temp. After it locks temp, temp should come down through here and run this whole set of code, and cache A or cache B should get filled up, whichever one, ends up being used. So we know that use A is always going to be defaulted to false. So knowing that that's the case, we should be able to say, all right, we're always going to be using B, but we'll go ahead and use an if statement here just in case. If temp.useA or cache item cache equals temp.cacheA, else cache equals temp.cacheB. And then here what we're going to do is we're going to say, all right, now that we have an updated cache, we want to take this story cache, we want to lock it, and we want to update, well, actually, we don't even have to lock it right now. What we want to do is we want to say if sc.useA, and this is going to be a little bit confusing, so bear with me. So if it's sc.useA, so if this story cache is currently using A, we're going to update B in the background while it's doing its thing. So we're going to say sc.cacheB is equal to cache. And then once we've updated that cache, we're going to say sc.mutex.lock. And then we're going to say sc.expiration equals, this isn't making much sense. So originally I was going to have us rotate between cache A and cache B inside of this story cache. But what we're doing here is we're just creating a brand new one because it's easier, because we can just call stories on it. So we really don't need this cache A and cache B stuff. Really what we can just do is just get rid of all this. Get rid of this whole line. Make this just be the cache. I'm going to come down here through the code, and I'm just going to say return sc.cache, nil. And we're doing something similar, it's just not quite the same. I think this it makes more logical sense to me. Sorry, I wanted to do sc.cache is equal to stories, return sc.cache, nil. We don't need this use A, use B type to start, figuring out which ones we're using. So this code gets much simpler, which is nice. Coming up here, you'll see that we can just get rid of all this. We're going to say sc.mutex.lock. So what I'm saying here is I'm going to try to lock this story cache up here, even though we're not going to be up, even though its cache isn't invalid, or we don't necessarily know it's invalid. I'm going to try to lock it. I'm going to say the cache is now going to become temp.cache. And then I'm going to say that the expiration is now going to become temp.expiration. Because we know that these two values are, we just got them. They're better than what's in here because we just did it after 3 seconds. And, so they should have a little bit later expiration date than what's currently in the story cache. So now that we've done all of this, we can now relock that mutex, unlock it, and let our code sort of continue doing its thing. And what this effectively has done is every 3 seconds this ticker is going to go off. We're going to take the story cache, we're going to lock it momentarily, we're going to replace these values real quickly, and this should be much, much quicker because, before whenever our cache expired, we'd actually have to hit API endpoints, slow down our whole server, wait for that to happen. But with this one, really what we're doing is we're just overwriting some data real quickly, then unlocking it again, which is a much, much quicker operation. So the user shouldn't really see this, this delay that they're normally seeing. And then the last thing I'm going to do real quick before we move on is this ticker part. Right now we're saying that we don't do this until 3 seconds have passed. But if we take this line, move it to the bottom of the for, we'll actually populate the story cache as soon as our server starts up. So the handler will start up, our server will start up, it'll call handler here. Handler will come in here, and it'll immediately kick off this go routine, which will populate the story cache and, wait for 3 more seconds to go do something else. So even if we refresh the page instantly when the story starts, or, really quickly, it should actually have a story cache already populated as long as this right here set of code finished. All right, so let's go ahead and try this out, see how it works. I doubt it's perfect, but you can see here the very first page load was pretty quick. We're going to keep reloading. I'm just going to go ahead and just try to make sure that it always is pretty quick. We know that our cache is 6 seconds right now, but you'll notice that I'm pretty much never running into a slow page load. So again, this is just one of those cool things where if you design a good cache and you do some stuff like that, you can actually keep it updated and keep it with good content without the users experiencing that really slow delay. And if you want to see a video that's similar to this, I don't have the link, but there's a video I think on YouTube of some members of the Go team when they moved, I think it's tip.golang.org. Is this what it was? Yeah, so Tip has like the most recent version of Go, if I recall correctly. And there's a video where basically they build this website. They take a Google App Engine environment and they build this. And the way they do it is something very similar where they have the current version that the server is serving, and they have a second version. And they build the second version in the background whenever they notice a change. And as soon as it's all completely ready, they take the web server and they tell it to start serving that one. And they then destroy the first one, so they don't need it anymore, so they get rid of it. And it's kind of like having 2 versions that you're alternating between, but in reality, you're just getting rid of the one you don't need anymore, keeping the one you need, and you just rebuild a new one whenever you need it, so that you can point the server back to that one. So that's roughly what we're doing here as well. I think that's good enough for what we're doing. This is a little bit. You'll see, this type of code, maybe it would make more sense to build this into the cache somehow. That's what I was originally going to do with cache A and cache B. You could build your story cache in a way that you could actually have it running. Maybe you just call a function and it updates the alternate cache. So maybe it'd be something like sc.refresh, and maybe refresh, what it does is it would take cache B, or whichever cache you're not using it, fill it in with data, doing something like this. And then as soon as it knows it's good, it would lock itself, alternate which one it's using, and then go ahead and change the code. So it's not impossible to do it the way I started with cache A and cache B. I just like this way because it, in my opinion, it's a little bit clearer what you're doing. You're essentially just getting a whole new cache and, grabbing all the data, and then you're just copying over the important pieces with the mutex locked so that you know that it's not going to cause any erase conditions. Okay, so that's it for this bonus. One more bonus video if I get time to record it. I'm going to release everything regardless, but one more bonus video I'm going to try to do is creating a worker pool for the for this part down here. So when we get the stories, I'm going to try to create like a worker pool and show you how to communicate with it and not actually create a Go routine for every single web request you're making.